We've got the depth cameras. These are the robotics. I say robotics because that's the common use case, but there's so many other use cases where you need to have a machine see depth, and object detection and depth and AI. And this is a typical, we've got like a dozen different cameras or depth modules that go into like robotics to, even on their hands when they grab things. And then the second main new product line that Mike was talking about is the facial authentication devices. And like this is the actual camera, but when you look at like the embedded stuff, look how tiny this stuff is.
Okay, good morning and welcome back to another episode of Making It Happen by Sims. Today I'm joined by the guys at Intel RealSense, who are slightly different time zones to me. It's afternoon for me, but morning for you guys. Joining me today, I have Michael Nielsen and Chris Matthew, who will get some introductions from shortly to give you, our audience, and obviously myself to some extent, a deeper look into AI and computer vision innovation, really, and what they're involved in and how they're really transforming the biometrics, identity, and automation markets, I guess, at the moment. So good morning to you both. How are you?
Yeah, great.
Thanks for the time.
No worries. Thank you for joining. So great. Before we get into the technology side of things and the problem solving at RealSense, if you could just both kindly introduce yourself, give a bit of information on your background leading up to RealSense, that'd be great.
Mike?
Go for it, Chris. You go first.
Okay. My name is Chris Matthew. I'm a serial entrepreneur. I've built and sold 5 emerging tech companies in the past before joining Intel. And at Intel, I was what was I?
Entrepreneur in
I was an
residence.
entrepreneur in residence, like Mike. We were both helping internal projects, spin them out as real new tech companies. And then joined RealSense full time. I'm the chief developer evangelist for RealSense and a hacker, if you will.
Great. Nice to meet you.
I joined Intel maybe 5 years ago now. It feels like it's been a wild ride, obviously, for the last 5 years. I also came in, like Chris said, as an entrepreneur in residence to help out on the incubator. We did a bunch of different ventures, everything from like green energy to with hydrogen extraction, all the way up to high security stuff with homomorphic encryption, then all the way back to computer vision applications. So there's a pretty big spectrum of stuff that we covered over the last few years. I got the opportunity to come over. I got a really long background in security, both at startups and in big companies. And I ran an incubator kind of thing at another big company before. So when we were about to relaunch the facial authentication products, I'm looking down at the camera on my desk. I got a prop. I've always got a prop. I gave away my favorite prop to somebody. A customer needed one.
You can always show the prop. We're very happy to see it. See, Chris has got one.
When we were about to relaunch this, Mark Uhura, the general manager for RealSense, asked me to come on board and help out, kind of shake the business side of things out, and it's been a fun ride.
Great. And are you guys all based out in the state? I think I was speaking to Chris Pryor. You've got some guys out in Israel. How does it work for you guys?
Yeah, we got a relatively sizable crew here in the Bay Area. We've got maybe 20 people or so here in the Bay Area. We've got 100 and change in Israel, a chunk of folks in China as well, and then some folks just kind of scattered around the U.S. and different geographies.
Great. Okay, great. Well, thank you for that introduction. So let's kick it off. Let's talk RealSense and let's start with the tech and the evolution of that tech, I suppose. And firstly, let's start with you, Michael, and let's just go to the original vision behind RealSense and what you know since joining the company, and just give us a bit of an insight into how RealSense has evolved over the years.
Wow. So it started out as what we call perceptual computing, and the whole idea is that we know that computers, machines need to see in the human world. So we started off with some 2D imaging, 3D inferred, and then eventually figured out that stereo depth imaging is the way to go. As we kind of fast forward over that journey, it's been like a 12-year journey for the organization. Productized maybe 8-9 years ago, and then where we are now, we're now seeing, I think, the tipping point where machines just see and act and respond better than humans do. In the biometric world, that's 100% true, right? I can show you images of like pairs of people, and you guys are probably better at it than I am, but I can't tell the difference. machines can. And it's because they're looking for things that human beings just aren't trained to do. I mean, it's not like the mantis shrimp of the computer world, but they see in a different dimension than humans do.
Mm.
So whether it be on the security side for biometrics or on the robotics side for everything that we're doing at the edge, there's a huge opportunity to really help machines do things better and safer than people do, especially as they operate in the world where people live.
Mm. Okay, great. And I mean, just in terms of hardware and software, I know you guys do a lot on both sides, I guess, and linking it in with developers, from what I understand. And obviously, there's been some market adoption over that time, and markets have changed. Chris, are you able just to talk us through the major milestones that you've seen and the breakthroughs in the real sense development, probably just in the time that you've been there, or over the past 5 years?
Yeah, well, to extend on where Mike was going with that earlier, we've got really two main product lines.
Mm.
We've got the depth cameras. These are the robotics. I say robotics because that's the common use case, but there's so many other use cases where you need to have a machine see depth, and object detection and depth and AI. And this is a typical, we've got like a dozen different cameras or depth modules that go into like robotics to, even on their hands when they grab things. And then the second main new product line that Mike was talking about is the facial authentication devices. And like this is the actual camera, but when you look at like the embedded stuff,
Mm.
look how tiny this stuff is.
Yeah.
Full blown, and Mike can go into grave detail on the types of technology that's built into this thing, doing all the algorithms like on device, which is just crazy. But um, I've seen like a revolution, like the humanoid market, like everyone's buzzing about all these humanoids, robots coming to market. I think about 60% of them run RealSense cameras inside of them. So it's the state of the art de facto standard robotics camera.
Mm.
But other use cases, like I just touched on, are things like Chipotle, where they're looking at bins of ingredients and being able to automatically tell or notify someone to fill up an ingredient bin when it's running low. So
Mm.
all sorts of use cases from, AMRs, we call them. They're the autonomous mobile robots that are moving, forklifts, around big giant warehouses to, robotic dogs patrolling fabs or places of business. Um, it's quite amazing to see the real sense developer community like all over the internet.
Yeah, great. And let's go. Obviously, you just showed some products there. So, in terms of form factor, and I'm assuming these got these things that they're able to withstand industrial sort of environments. Talk to me a bit more about the form factor and the sort of the ruggedness
Yeah.
and how that works.
Yeah, so like I said, there's about a dozen different types of cameras. What I showed you here was kind of a smaller one for like I think it's like a 2 meter range is what it's got.
Mm.
When you talk industrial, this is like an example of a more industrial one rather than like a USB connector. It's got what we call a FACRA
Mm.
GMSL connector, which is really, really fast, really, really reliable. And the camera itself, this particular one is what they call IP65, which
Hmm.
means it's rated for like dust and weather on this particular one. So yeah, it's a whole and it goes a further range than the one I just showed you earlier. But these also come in modules instead
Mm.
of the enclosed, hardened aluminum pretty case. So if you're building a kiosk or a robot and you just want to, put something inside of it, you can get just a tiny little module and embed it in a product.
Yeah, great. And so just hearing that and looking at that, it's very much they're plug and play products. Is that the best way to describe them?
Yeah, absolutely. And we have an open source SDK
Right.
that makes it really, really easy to build to for like, hardcore C++ guys all the way, like to Python and REST APIs, to make it really simple for all developers to get engaged. And the depth cameras support ROS right out of the box. So if you're building a humanoid and it's running the robotics operating system, it just plugs right in and starts streaming all the depth sensors. And, also another point about like the RealSense cameras and algorithms, they're amazing at what's called VSLAM. visual simultaneous localization and mapping,
Mm,
where the robot always knows where it's at in time and space. So as it's moving around, it can visualize, and say, hey, that's a window. I recognize the spot I'm in. So, there's no GPS inside of buildings. So you're building this map of the
mm,
whole space and doing obstacle avoidance, all with these cameras. And to Mike's point earlier, these things can operate way faster than human eyes and human brain. Like you once you train your humanoid or your robot what to do, it can operate 2 to 4 to 10 times faster than a human and
mm.
still be 100 better accuracy than human eyesight.
Yeah, no, great. And I guess just on that point, and we'll touch a bit more on industries and use cases and even some of the niche stuff that you guys have been doing, because I imagine it's all out there. But in terms of feeding back analytics and metrics, especially I'm thinking automation of factories and even surveillance and even on site in industrial plants. These things in terms of surveillance and security and collision avoidance and human object avoidance, you must be able to feed back some pretty cool analytics and data to people, right?
We can, yeah. So on the biometric side of things, we don't necessarily operate in surveillance applications per se because we don't maintain like a database of people. But what we do, it's explicit opt-in. So let's say, Drew, you walk up to a door, you register to be, or you've been registered by your security group to be in that company or in that facility. We can use the capability to do real time, like should you actually be physically in this space? And we're actually seeing a lot of applications right now where, specifically for safety, for employee safety.
Yeah.
Think of like a mine where you've got to pull everybody out of a facility during a detonation event, or you've got a safety event that you got to do counting. So historically, they'll just go through and they'll count people, and you've got somebody with a clipboard checking off names.
Mm,
Here, you can do it with biometrics to make sure that you actually have seen everybody walk back out of the facility because the false positive rate is effectively zero.
yeah.
So there's some really cool applications in heavy industrials for both the robotics and the biometrics, specifically around safety and just speed.
Yeah, and you guys said that you're very much focused on a global market at the moment, and obviously we're based in the UK and Europe, and we're just looking into that. So where are you seeing the exciting projects at the moment? Is it very much global, or are states quite ahead, or where is it happening at the moment?
I kind of categorize it, and then I hand it to Chris. I kind of categorize it three different ways. There's the the mainstream acceptance that we're seeing right now in biometrics. People have finally gotten past I use this to unlock my face or to use my face to unlock my phone, right? So people have gotten a lot more comfortable with using their own biometrics to just have access to services.
Mm,
So we're seeing that tipping point happen on using face for a bunch of different services downstream, whether it's getting into a football game or paying for lunch, et cetera. And that's global. It was led largely in Asia, not surveillance wise, but like convenience wise, Japan, South Korea, and that's scaled out. So I think the US is actually a laggard here. I think Europe is actually way farther ahead. And frankly, part of that is because of GDPR. People actually have guardrails to where they know that if they deploy within those guardrails, they're good. Whereas in the US, we have 185 different regulations, none of which actually match each other. So there's no real specific guardrails on it. Um, Simultaneously, the autonomous mobile robot market is exploding worldwide as well. So I think in the UK and across Europe, we're definitely seeing a lot of traction as a business, and that's pretty consistent around the globe right now.
mm,
And I think the third one is, and this is Chris was touching on this a few minutes ago, the humanoid robot. You're not seeing it so much globally, but China is going bananas on this right now, and they're leading the world on this. I don't want to. I don't subscribe to the idea that China's a laggard. They're way ahead, and they're going to lead the humanoid market. There are a number of innovators in the U.S. trying to do the same thing, but we're going to see applications specifically in heavy industrials in super dangerous situations where you need to have humans and robots operate in largely in human space, where you don't necessarily want things on wheels because it's a dangerous situation. That's then going to scale out very quickly. So we're seeing it's effectively a compression in timelines.
yeah.
Whereas before the adoption would take years, now we're seeing it compressed down to like weeks and months. It's a very, very different market now.
Yeah, got you. Chris, have you got anything to add to that?
Just I was going to, yeah, to Mike's point, we call the industry calls those cobots. So like collaborative robots where they're working side by side with humans. So they've got to have a lot of safety capabilities so that they don't squash a human or hurt a human when it has to stop. But yeah, it's all over the place for automation. Like you're seeing a trend too around lights out automation.
Mm.
And what they mean by that is no humans. Like fabs and manufacturing facilities are entirely run by robotics.
Great, got you. Okay, great. So another area that I wanted to touch on, and what we're seeing quite a bit, is around retail. Talk to me a bit about how the brand RealSense is changing sort of in-store experience and streamlining operations there. Are you guys working heavily in that space?
We are, yeah, I can touch on it a little bit, and I think Chris, you're doing a bunch of work here as well.
Yeah, I mean, I can give one.
Go for it.
Go ahead, Mike.
No, go ahead, go ahead, go.
No, I think I'm having internet trouble. You go ahead.
Okay. So there's the traditional stuff that's transforming, and then there's the new things that are transforming. So I was in a mall in Dubai fairly recently, and one of our customers has cameras all over the ceiling. I wish I could show you a picture of it because it was pretty interesting implementation. But you walk in, they use facial authentication because you've already opted in. That you've said I want to use the service. So if you walk in the store, it knows I'm Mike. It's got my credit card info because I've already asked it to secure that information. I go in, I pick something off of a shelf. Let's say it could be anything from an iPhone to an Apple. In this case, they had literally physically both of those. They had like some fruit over here and they had some electronics over here. They use a combination of things like weight sensors to see has it been removed from the shelf, right? So you don't like shove something onto the shelf. They also will do reconciliation. So if I like pull an iPhone off a shelf and I know it weighs, I don't know, whatever, 200 grams, and I put something else that weighs 200 grams in that shelf, they're using our cameras to say, okay, well, that doesn't go there. This is not an iPhone. This is something clearly very different. But it's a really seamless store experience. And while we haven't seen broad scale adoption of that just yet from like a pickup and takeout perspective, I think it's coming. We've seen a lot of fits and starts on this one so far with different companies trying like smart shopping carts. Great idea. Some challenges there. Some pickup and walk out by using it just at the exit. Well, you can obscure what you're taking out of the store. But in terms of like tracking in the store, what's been picked up off of the shelf, that's a huge new market that we're seeing happen. We're also seeing some really cool innovations in smart checkout for more traditional applications for self-checkout, where I've learned a lot about fraud over the past couple of years, but someone will take, I don't know, again, use the phone, and they'll have like something else behind it. I'm trying to find something I can use, but it's like a chapstick. They'll scan the chapstick, and then the chapstick will it'll get buzzed up as chapstick. So the person that's watching sees me scan the phone, but the chapstick comes up as $1.29, and the phone that costs $1,000 doesn't get picked up.
Yeah.
Um, we're seeing some applications of the technology say, no, there's a phone there. Yeah, there's a chapstick there too, but for anti-fraud at the checkout, and also to speed up the checkout because self-checkout can be kind of slow. So just on the user experience side in retail, it's been huge. And then obviously there's security, there's real-time inventory tracking, there's logistics in the back of the house for warehousing and loss prevention. There's all these different applications that are really human intensive before.
Yeah.
And just the false negatives were huge because you can't have humans everywhere looking at everything. But cameras are cheap and you can stick them in the ceiling and leave them there. So
Yeah.
it's been a huge change, especially with AI, and it's all being done at the edge. When you're essentially processing, it's a bit of a mess, but when you can set triggers out at the endpoints and then call a person to go out and take a look at something because they think it's a real event, like a spillage on an aisle, you want to know that in real time.
Yeah.
So somebody doesn't walk by and slip and hurt themselves, right? So really cool applications across the board.
Yeah, that's really interesting. I think that the way I'm kind of, sorry, Chris, that the way I'm kind of understanding what you guys are, the way you work, you had the technology, you work with businesses, and I imagine they're almost, depending on the business that approaches you or you approach them, they're almost bringing you into new use cases and innovations all the time. You're becoming understanding of what the technology is capable and what it can do for a business on a constant basis, right?
Yeah, we're getting pushed really hard by our customers right now
Absolutely.
for all kinds of really interesting innovations. Go ahead, Chris.
Yeah, I was going
100%.
to expand on what Mike was saying at the end. I don't know if you can see this, but this is a robot from Simbi Robotics named Tally. This
Hmm.
thing has got like over a dozen RealSense cameras in it, and it roams like grocery stores up and down the aisle doing inventory assessment, real-time inventory analysis and assessment. It ties right into the systems. It can order more products if the shelves need them. And it's kind of got a friendly little face on it so that it can avoid customers walking down the aisles, and even kids like walk up to it and talk to it, and it kind of beeps back, and so it's kind of cute but very very functional, and it can run 24/7 at a grocery store.
Yeah, I think that's the point with robotics. Obviously, in the back end and in factories and stuff, it's not too much of a worry about what they look like as such. But I suppose what you're describing there is if we're going to make this work in tandem with human beings, we're going to have to give it a bit of a friendly vibe and make it work that way, right?
Yep.
Yeah.
Yeah.
Yeah, you're seeing both. I mean, you're right. The back of the house where people don't need to be, you can
Mm.
fully automate, and it can. There's less of a security concern about security and safety because people aren't there. But we're really seeing a shift to robots operating in the world where humans are. Everything
Mm.
from like agricultural robots to stuff in store with Simbi to a whole bunch of other use cases. We've actually seen things like humanoids being assistive for the elderly in Japan,
Mm.
where it's a combination of both comfort because they have someone to physically, not someone, but a robot humanoid to sit with, but also to assist them in in rising and moving and things like that. So we're seeing what was 5 years ago totally science fiction starting to really land,
Yeah.
uh, and the speed is extraordinary.
Yeah, great, awesome. And I just wanted to touch a little bit more on form factors and probably around optimizing for the edge. Obviously, I explained to you a little bit before that our dealing here is largely memory storage and working a lot on server, and we've seen, the EDSFF family form factors, sort of, just trying to make the best of the space. So in terms of what you guys do, I know you do the modules and I know you do the cameras and it works that way, but are you being asked to sort of, in terms of roadmaps for different form factors to change the size of the technology? How does it work for you guys and what do your roadmaps look like?
Want to go ahead, Chris?
Well, what made me think of something Drew was saying, you'd be better at answering this question, is just take the facial authentication camera. Like
Mm.
all of the facial prints, face prints are all stored on the camera, the algorithms on the camera. Like this is designed so that it's self-contained, no cloud required, but you could, infinitely scale this if you needed. Mike, did
Yeah.
you want to talk a little bit more about that?
Yeah, there's we're getting pushed in multiple dimensions here, in a good way. So we focus on, we've got to go to some lowest common denominators, right? So like the camera that Chris was just showing, the F455, uh the privacy preservation is paramount. It's the number one thing that we have to do on here. So I don't know who you are, I don't keep your imaging, I don't do anything like that. This is just I'm developing a template against Drew.
Yeah.
Drew's already said you can do that. Now, if I see Drew again, I can do a match to match. I still don't know who Drew is, but the camera can say it was you here and it was you here. We're being asked to then extend that capability, not because facial recognition doesn't exist in the world, but because we're really good at the privacy part of it. We're being asked to extend that capability software-wise into bigger environments where people have opted in. And again, it's
Mm.
particularly around safety. Someone goes into a facility and they accidentally take a right turn instead of a left, and that's a dangerous area for them to be in. You got to make sure they don't get hurt.
Yeah.
So we're seeing a bunch of pushes there. So we're expanding in the software realm on biometrics, and at the same time, we're also expanding in the software realm on robotics and retail and other applications, where you'll see. Can't talk about what they are yet, but you'll start to see some really valuable stuff coming out of us from an algorithmic perspective that can help robotics manufacturers and logistics operators turn this stuff on like now, as opposed to spending 2 years to do integrated development. One of the biggest issues that you see out there is, like Chris was saying, around VSLAM, around SLAM. Developing a SLAM system or taking an off-the-shelf SLAM and making it work with off-the-shelf cameras is extremely hard. So we're trying to make things like that a lot easier for our customers too. So we're being pushed on the form factor side of things, GMSL, Ethernet connectivity, all kinds of different connectivity capabilities,
Yeah.
as well as like the optics and field of view and depth and everything else, in addition to the software side of things for algorithmic processing all the way out at the edge.
Okay, great. And is it just GSML and Ethernet, or do you have USB or MIPI or anything like that as a connector?
A USB for sure, yeah.
Yeah.
And like I said, we're getting pushed to do a whole lot. We've got partners out there as well that actually take our modules and our peripherals and they'll wrap them in hardened enclosures and casings. People like From Us, for
Yeah.
example.
Yeah.
They are one of our they're one of the leaders out there where they can take it and they can harden it for any environment and use external connectivity to do that. So
Great. Okay, great. And Chris, you mentioned a figure earlier. I think it was a 6% market share, and I can't for the life of me remember what it was around. I think it's around robotics potentially. In terms of competition, I'm sure you get asked all the time, but it's just good to know, without naming any names really. But what do you look like in terms of comparing against competition, and how much of it is there out there for you guys, and what differs you really?
Well, you know what, let me start it. Let me have Mike follow me up because he's a lot closer to that the data. But there are, it seems like most of the competitors I bump into are in China. And, there's a lot of geopolitical, turmoil happening in the world, which I think makes our camera, the preferred non-Chinese camera on the market. But the technology we have, as Mike said, we've been at this 12 years with Intel investing in R&D and like some of the facial authentication, I believe we've been working on for 10 years before releasing this camera. So there's a lot of innovation that I feel we're ahead of the market and leaders in the space, not only of facial authentication, but depth, robotics, 3D cameras. They're complicated. When you look at this thing, I mean, there's things like IR sensors, depth sensors, RGB cameras. There's a lot going on in here. Even in the facial authentication camera, we talked about, it's stereo. So instead of like a 2D camera, it's doing stereo infrared and it's doing anti-spoofing. So it's also doing some light reflection. Are you wearing a mask, like a Hollywood Mission Impossible mask? Versus, is this a real face that I'm looking at? Then I wanted to add one more interesting point. It's kind of a follow-up of what Mike was saying earlier. Most of the algorithms today are based on 2D cameras. But when you start looking at some of the things we're doing with 3D algorithms, like object detection, but in 3D instead of 2D, that takes down, all the false positives and the accuracy, through the roof up on, yes, that is a human at my doorbell. Make sure that, don't send me a false notification saying I think it was a human when it was a raccoon or something.
Right.
I think one of the major areas we get feedback on from our customers that they like. I mean, the tech is really solid, but the APIs and the SDK. On the face side of things, it's a really well set of enumerated REST APIs that you can call either from web services or from direct on device. This on the SDK, like Chris said, it's open source, so we're very transparent.
Great.
There are competitors out there that are not open source, and frankly, we think there may be some IP leakage that may have happened there. But we really focus on the developer community. I mean, Chris is leading the army on that one, but we're really focused on the developer community and making it easy
Yeah.
to get up and running with the advanced capabilities as opposed to making it easy for a science project.
Great.
Let me add to that too, Drew. I was experimenting. I said, let me see if I can write a game. Like I was just playing, like what else could you do with these cameras? And I wanted to write like a Pong game. Like the closer you get to the camera, like the Pong paddle would go up, the further away it goes down. I opened up my cursor and Copilot AI, and it literally wrote the whole game for me in 15 minutes without me writing a single line of code. It knew the RealSense camera. It had access to all the examples on the GitHub repos. It knew how to do object detection, depth detection. Like I just watched it. It was just and like first pass run, and I'm like I'm playing a game here with the camera. So I was like blown away at Copilot being able to leverage the open source SDK to build really cool things without me typing a single line of code.
Amazing. That sounds amazing. Great. And I've got a question for you both here, really, and it comes in just a potential of AI vision, really. And I would like to know, really, what's one thing that people sort of misunderstand or overlook about it that you wish more people realize? And I suppose what I mean by that really is, and what I'm asking is, maybe people don't understand how accessible it is, or assume that it's only for high-end robotics. So, overlooking really how important depth might be compared to traditional 2D vision, really. So, what are your thoughts on that?
I kind of answer that two ways. And the second one's much more of a Chris answer, frankly. But the first is that there's a lot of really good science going on taking standard 2D RGB cameras and then inferring what the object is on the other side of it, and then inferring the distance to that thing. And they're reasonably accurate. But when it's accurate within a meter over 6 meters, that's very, very different than being accurate within a centimeter over 10 meters, right?
Hmm.
So, pardon me, having and the reason that's important is not just because I really care, like, is it a box or is it a car? Um, I find need to know the difference between a person walking up with malicious intent to a camera, or not to a camera, but to another human being. And I've used this example a bunch of times, but the action of going in for a hug is kind of similar, if you don't know what you're doing, to the action of throwing a punch or to taking a weapon out of a pocket. So having that depth is critical in knowing the actual trajectory of the arm and the motions that go along with it. You can train 2D to do some of these things, but when I see companies coming out of the chute, and I'm not going to say their name out loud because it's not fair, but when I see companies coming out and saying we do really fine grain detection for, like, wildlife, for example, and it shows me a picture of what is clearly a pig and it says a wolf, that's a problem, right? And it's because there's a combination of the training that hasn't been done properly, as well as the actual feature differentiation that you can only get when you have depth.
Great. Chris?
People think that our cameras are expensive. Well, I mean, you get what you pay for. That's they're high quality. The IP65 rating, et cetera. It takes a lot of work to build that. However, we have just recently launched what's called a D421. This thing is an $80 robotics depth module. So I mean, to say that I've got to, like, spend $500 on a camera or something like that is not necessary. Like this works not only for the hobbyist or educational market, but real humanoid robotics. And I mean, if you can look at this, it's on like a plate, to mount it on, but it's just as thin as that other facial authentication embedded device I showed you earlier. So I mean, it's $80. That's pretty remarkable.
Hmm.
And
Yeah, fantastic.
that's really important. Like, if you put those two together, right? On one hand, you can get a very affordable small form factor depth module, and on the other side of things, you know that if you're using depth and algorithms that are relatively well proven, that have been trained properly, you can get really high efficacy results very quickly because of the SDK.
Hmm.
That's when things start to accelerate in the market. Where that's what we're seeing right now as a result. Are people like, okay, I don't need to go spend 2 years and hire a bunch of AI guys to go develop a set of models, nor do I need to hire a bunch of optical experts and create my own dedicated modules, because everything from, like, calibration, positioning, all that stuff kind of matters. And not,
Yeah.
I say kind of matters. It's really critical. So getting that right at the shoot's really important. And if you take a couple of 2D cameras and think you can do stereo, if one of them moves a millimeter or gets jostled and it kind of like rotates a bit, your calibration's gone.
Hmm.
So those are the things that we solve for, so that when it gets into the real world, you don't take something that you did a POC around and then you go run it around the street, hit a pebble, and suddenly you're like, now I got to rewrite the algos because the cameras are out of calibration.
Yeah,
So
got you. Yeah, no, that's great. That's really, I got some real takeaway from that, is that very much it's more affordable than you think, and really, you guys, the open source developer community, and what you guys can do there in terms of software is very important to show what this stuff can do. So that's really, really awesome. And I just want to round off to both of you, and really just around industry and AI vision for the next 3 to 5 years. Where do you see the biggest growth in terms of industries, and what's the next wave of adoption going to be?
I if I split this into two, I don't have my badge handy. It's in one of my travel bags. Sorry, but I'd like to see plastic badges just disappear. And I think we're at the cusp of people are going to move to these, obviously, to tap in to get into work because no one leaves the house, forgets their phone, and still drives to the office. But I've done that with my badge at least 10 times in the last 6 months. Um, I think using our face for services is going to gain mainstream adoption. I fundamentally believe that because it's just easier. And as long as you trust the service, right? If suddenly I find out that the organization that I'm using to get into the football stadium is giving my data to the local police department, that's a very different situation. But as long as we have that trust, I think that tipping point is gonna happen. And simultaneously on the robotic side of things, what we're seeing right now, that tipping point has happened. The public hasn't seen it yet because a lot of it's happening behind in factories and in operational environments that we don't physically see all the time.
Yeah.
But that shift has happened.
Great. And Chris?
Yeah, I agree with everything Mike said. Our face is going to unlock everything in the near future. I think robotics, people think, oh my gosh, it's a $50,000 robot. I'll never buy one to cook meals and stuff. But what I'm seeing is that these things are going to be robotics as a service. So you'll pay 500 a month or something like that. You'll basically lease it and get free updates, as long as you're leasing it. So I think it will become super affordable where the whole world will it'll be normal. It'll be normal to see humanoids in your house, lawnmowers, robot mowers, mowing yards. Like, I think it'll just be drones delivering last mile groceries. I think all of that's moving at warp speed. And you'll see RealSense cameras on all of it.
Fantastic. Great. Well, guys, look, I want to thank you so much for taking the time to come on this morning and give us, our audience, and obviously myself, to explain just much more insight into this. We are actually demoing and showing some of your products at a show in the UK called Hardware Pioneers next week. We're going to be doing more of it, so please come and speak to us, Sims International, about it. But again, thank you so much for your time, and we will catch up soon. Cheers, guys.
Thanks, Drew.
Likewise, thank you.